Recursion in Python is a function calling itself. Let's build a factorial function. This is the factorial function. It takes a number as argument. The base condition is true when num is 1. Then it returns 1. When num is not 1, it gets to the return statement and returns num multiplied by factorial of num minus 1. Factorial of 5 means num is 5, not 1. So this returns 5 multiplied by factorial of 4, and factorial of 4 is 4 multiplied by factorial of 3, and so on until we have 5 into 4 into 3 into 2 into factorial of 1, which is 1. Multiplication of these numbers gives us 120. This is a function that adds the first n natural numbers. If num is 1, it returns 1. This is the base condition. Other times it returns num plus sum n of num minus 1. Sum n of 7 means adding 7 to sum n of 6. This means adding 7 to 6 plus sum n of 5, and so on. This is until we have 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. This is 28. Let's build a Fibonacci series. Write a function that takes from the user the number of numbers to print and prints the Fibonacci series up to that length. Make use of recursion. A and B are 0 and 1. Then we ask the user about how many numbers to print for the series. This is 8. Outside the function, we print the numbers 0 and 1 ending with a space and not with a new line. Function fibr takes the number of items to print. If this is 2, the function returns. This is the base condition. Now we'll modify global A and B. A is now the value of B and B is the sum of A and B. Then we print the value of B ending with a space and then make a call to the function with num minus 1 as argument. Let's make a call to this function. Num is 8, not 2. A is now 1 and B is 0 plus 1, which is 1. And this way it prints out 8 values, adding the value to every next one. 2 and square. Write a function that prints a certain series. The first number it prints is 1. For each number it prints, it adds 2 and squares it to obtain the next number to print. This function takes in the number of numbers to print. Define a function 2 and square. If count is 0 or less, return. This is the base condition. Add 2 to num and raise it to the power of 2. Print it and reduce count by 1. Then call this function on count and num. Calling this function on the value 6 prints 6 values this way. 1 plus 2 square is 9. 9 plus 2 square is 121. Write a function that recursively performs a binary search on a list. A binary search is where it takes data in ascending order, the value to search, and the start and end indices of the data. It first checks at the middle of the data. If the value to find is equal to the value here, it returns it. If it is smaller, it searches in the left half, else the right half. So this cannot find 25, so returns minus 1 and finds 21 at index 4. Counting. Without using a loop, write a function that prints numbers 1 to 100. This is the count function. To it, n is 1 by default. It prints a number, then if it is less than 100, it makes a call to itself with the next number. This way it starts printing from 1 and keeps printing until 100, and there's no need to use a for or a while loop for this.